Hello and welcome to the Failsafe planning chapter from the KNX Advanced course. My name is Amir and I'm going to teach you and provide you some nice information based on the book, the standard topics, to learn more about it. Please consider it and let me know if you have any questions by email or WhatsApp. So why we should plan in a safe way in KNX? The book said many KNX systems that are installed nowadays fulfill security and safety related functions. If these type of applications are required, software and hardware measures should be taken into account to make the KNX system fail safe. It means some important information and data should never be vanished during the transmitting. Okay, so we should make sure about the functionality in security and safety issues in KNX systems. Examples of this type of requirement includes alarm functions, very important. Monitoring systems, window and doors, so we use it, for example, in security systems, these type of information. Intruder and anti-theft alarm systems. Remote signaling, telephone and web. For example, you use some data to control the system from remote, in a remote way, okay, by the web or whatsoever. The key functionality. The information and data that is coming from the fire detectors and water detectors that is provide for us safety issues. And control of devices and applications whose failure could lead to consequential damages, like wind sensor for shutters. It is really important, for example, in control of the awning and shutters outside of the building, we should take care about the wind. If some strong winds happen, so we lost the awning, we should prevent it. How we prevent it? We use the wind sensor based on KNX. We use the KNX actuators, relay actuators, which provide us alarm functions, and we combine it to make the automatic actions in case of any strong wind. So this is the safe planning. From now on, in this chapter, we are going to consider some key examples, and you can always follow these and maybe more in your projects. First of all, we consider some nice information in software measures. Okay. For safety related reasons, it can be advisable to repeat telegrams at cyclic intervals to guarantee that the output device is set to a defined switch position if the transmitting device fails. A function that occurs frequently in KNX systems is the wind or rain alarm. The method of operation of a wind sensor is described in following slides. Okay, the point is we get the samples from the sensors. Okay, we provide this information in a cyclic way for the actuators. Whenever the actuators receive these signals, okay, the actuators make sure that everything is fine. But if the amount of this data or type of this data is changed, for example, it's a 1-bit data, it changed from 0 to 1, or the actuators does not receive this data anymore, the actuators act automatically and put the, for example, shutter in a safe position. Okay, so important things is always we use the data that is coming from the sensors in a cyclic way and make sure always we get it. And actuators are waiting for this data to take the right action in case of any fail happening. The information that there is no wind, for example, so now we are talking about the configuration of the system between the wind sensor and actuators. The information that there is no wind, it means logic 0, is transferred cyclically by the sensor if the shutter actuator does not receive a safety telegram. Safety telegram means telegram with the useful data 1 bit, that is 0 or 1. Always it should receive the 0. If the actuators does not receive the 0, within a defined period, the shutter is moved into the safety position, and any move, stop, and step commands are only carried out if the wind sensor has sent the telegram no wind present. Okay? It should be noted that only information no wind, it means logic 0, should be repeated cyclically in the KNX systems. The majority of shutter actuators carry out a movement command on receipt of the telegram wind present, logic 1. If this telegram is also transmitted cyclically, it could lead to damage of the drive motors in the worst case. So it is important that we should take care of the data that is coming from the sensor. Okay? As long as the wind sensor send the 0, the actuators make sure that nothing important has happened, and it can work in a regular way. But if the actuators receive 1, or the actuators does not receive anything, it moves the shutter to the safe position. But if something's happen and sensor sends 1 and 1 and 1, because it makes the actuators to act again and again and again, maybe it damages the driver of the motor. Okay? So, when configuring this type of cyclical monitoring, it should always be ensured that the monitoring time on the actuator side is selected as approximately 3 times as long as the cyclic time of the sensor. Generally, telegrams which are sent cyclically should not be sent at very short interval, as this would lead to an unnecessarily high bus load. Normally, it can be assumed that the new state will be sent immediately if there is a change in the state at the sensor. So there are some key points here. When we want to send the data from the sensors, okay, and receive the data from the actuator side, each 3 times that we send the data from the sensors, the actuators only receive it in a 1 time. Okay, this is the first key information. The second one, when we want to do the cyclical sending from the sensor, we should try to not select it in a very short time. It means, for example, every second sensor should send some data. It is not true for KNX because we make the bus busy. Okay, so we can increase it to 1 minute, 5 minutes, 10 minutes, 15, 13 minutes. Okay, it is important to take care of the cyclical timing of sending the data. And then the important things is always in parameter the sensor, or for example ask us if the change is happening, I should send it or cyclically or at change and cyclically. We recommend to choose the at change and cyclically. Okay, here are the example how we select the sampling time interval of the sensors and receiving from the actuator side. So if we send every 5 minutes from the sensor the data, in actuators we receive it every 15 minutes. This is a rule of thumbs in KNX systems and we recommend it to follow it. Okay, sensor repeats cyclically. Look at this diagram. The sensor sends to the actuators, okay, cyclically, and actuators receive the data. In event control, decentralized system, the majority of safety functions are based on cyclically transmitted telegrams whose transmission is monitored at another location. Okay, let's go for a nice example. We use the KNX virtual, okay? The virtual devices that KNX Association hopefully provide for us. We make a project. We use the KNX Association devices. We import the weather module, blind actuator, and clicks. This is a push button, okay? Please focus on the abbreviation notes like D12, D2, and D4 to make the right download, and always use the full download in KNX Virtual. Okay, so after we import it from the catalog view, we do some parameterization. We go for a weather station, weather module. We go for a channel 1 and set to the weather module add wind speed compare function. We put it on yes, and we said if it is more than equal than 4 meters per second, the wind storm, then you should activate the wind speed event. Okay, great. This information is coming from the sensor. But about the actuators for channel 1 from the blind actuators in KNX virtual devices, we activate the storm protection, put it on yes, okay? Then it provides us the wind alarm group object. Of course, by the push button, we want to be able, by the channel 1, we want to be able to control the blind. Great. Then let's go for group addresses. For the group addresses, we make the main group address, floor number 2, the middle group address, the function shutter, and then we make the control move, control stop, and status position of the shutter as regular, what we have in basic course. But we add one group address more, wind alarm. In wind alarm, we make the connection between the blind actuator and weather module. So look at the KNX virtual tab, blind plus plus. Here you can see that the wind speed, it's nothing outside, is 1 meter per second, okay? So now we can move the shutter. We click it in a long operation, and then it works. You see this shutter is going down. Great. Great. Okay, we do the short stop, we stop it. Some storm is happening. How we tell the device in KNX Virtual? KNX Virtual, we go for WS wind speed. We put it some number, for example, more than 4 because this is what we assign in a parameterization. We put, for example, 6, okay, and press. So look at here. This is channel 1, this is wind. It is going to the safe position. The safe position regularly is something that we want to close the shutter, and we cannot do anything with the button. You see, this is blocked automatically, okay? And this is the safety planning. So if we want to be able to control it by the keypad, or in here we call it clicks, we should change it, for example, to some number below than 4, like 2. And action. So now we can control it. This is a very, very nice example by the KNX Virtual. You can enjoy it because in a real life, to be able to provide such a experiment, you should buy the weather station that is so much expensive in KNX, like more than 500 euro, and also you should have some shutter actuators that fulfill the alarm functions. Great. So now you can do this exercise by yourself. The KNX Virtual is free of charge, and the ETS also, the demo version, is free, so you can enjoy it. Let's continue. The next important concept is priority of the telegram. Okay, so what is a priority? A further step in enabling telegrams, this packet of data in KNX, it means to be sent as quickly as possible, is the setting of priorities at the group objects. So we can change the priority in a group objects. Normally, these are set by the manufacturer. So normally we do not touch the priority. Okay, remember that. The priority of the sending telegrams of an object can be adopted individually on tree level with the ETS as required. The low operational priority, by default, all the objects in KNX follow the low operational priority, but we can change it to high and alarm also. And the system priority is for manufacturer, okay, and also for the ETS during the download. So you can see here to change the priority, you can click on a group objects, okay, in KNX, in ETS, and then from right hand side, properties setting, change the priority from low to high and alarm. But remember that there is very, very important notes. It should, however, be noted that you should not set a large number of telegrams on the same priority level like high and alarm, because it could possibly provide us some problems. We lost the data, some collision maybe happen, okay? So remember that if you want to change the priority from low to high and alarm, just do it for very few group objects. Some things that really needs it. For example, we have some information from the smoke detector, okay? Or some information from the water detector, or some information to the intruder alarm system. So we make the high priority for that. Otherwise, for regular functions, we never touch it and we keep it as low. Great. The next important things in KNX is what we should do for some key devices, like some actuators to run the pump or other things. In case of a startup, okay, the voltage of the bus is disconnected and coming back again, okay? We should consider what action the actuators should take it into account. The startup behavior of a KNX installation after voltage failure must be planned and checked no later than the handover stage. In most cases, it can be assumed that switch actuators retain their state after bus voltage recovery or switch off the outputs. For many devices, the status after voltage recovery can be set in the device parameter. Remember that nowadays, for the devices like the switch actuators, fan coil actuators, and similars, when you are setting the parameter, you can choose what is the action in a startup and in a very initial state. In particular, if irrigation systems something to provide the water for the trees outside of the building, or pump control systems or device controller which cause very high operating costs are implemented using KNX, the startup behavior must be verified and become a part of the acceptance report. So for some operations, it is very important what's happening if the voltage of the bus, I mean the 21 volts DC to the 30 volts DC, is disconnected and connected again. So what is the behavior of the actuators to control the pump and so on? So you should take consider and make sure that everything will be safe. Of course, the safe things is switch off everything. Yeah, great. The next topic is bus voltage monitoring. It is possible to install a conventional time relay in parallel to the KNX power supply to establish a voltage failure. Controllers, set point values, and other state in an installation can thus be reset to initial state. It means you can reset everything, okay, by some information, by some telegram, by some packet of data that is coming from the binary input that we connected to the conventional time relay. The time relay switches with a delay after approximately 30 seconds, and the contact is linked with a channel of KNX binary input. This binary input sends to a group address which reports a power failure and creates defined basic states. The following diagram represents a schematic configuration of this type of systems. Here you can see always we measure the supply voltage to the power supply, and we use the time relay here. And if some things happen, okay, we close the circuit of the binary input, we means the time relay, and the information is coming to some group addresses that make everything in initial state. Note that newer power supplies offer diagnostics functions. With these devices, a startup initialization can be carried out directly via the group objects. So nowadays, some companies like ABB and similars provide us the power supply with diagnostics functions. So we have the group objects that report us the input voltage, the output, the current consumptions, and many things. So we can use those objects to make the event in case of any power failure. More about these topics will be in chapter with the power supply and diagnostics function. If there is a request to transfer defined data to different group addresses on voltage recovery, controller can be used which is able to trigger a telegram and to send defined data to group addresses on receipt of these initialization telegrams. Look at this example. If some things happen, okay, the group object of the power supply with diagnostics or the group objects from the binary input, okay, can link with the group addresses to stimulate or to trigger the controller to make the pump off, okay, put the set point to 21, close the water valve and shut off the drive. Great. So we can do something in case of power failure. And this is a safe planning, of course. Okay. The next concept in fail-safe planning is we distribute system with controllers. So what it means? It means, for example, you have some touch panel in a room, okay? And then you control whole of the room with only the touch panel. But KNX said it is better to have some push button also in combination with touch panel. And in some cases that some fails happening to the touch panel, okay, you can at least provide some central controller by that push button. It means we have something in backup of the touch panel. And this is a distributed system with controllers. So what the book provides us, the book said each bus device has its own authorization and its own microprocessor. Yes, in KNX, each bus device has its own microprocessor. If a bus device fails, all the other bus devices functions without any interferences. This applies to all direct connections like sensor actuators. If logic modules are used, however, so this is so important. The important things is the book says if logic module are used, however, between the input device and the output device, the failure of this device means that the data transfer cannot take place. Another important thing is the book said if you use the logic module, okay, to make the connection or manipulate the data between sensor and actuator, and something's happened to that logic module, okay, you lost the whole of your logics. So it is better to use the logics that is embedded into the devices. So in this case, if you lose some devices, you lose only that logic related to that device, and still you have the operations from the others. So here there are two concepts provided there are two examples of distributed systems with controllers. First of all, you have backup, for example, to the touch panel with the push button, and then you use the logics inside of the devices. In KNX system that extends over several rooms, it is advisable to distribute the controllers to position several modules. The fault tolerance is thereby increased. It is also relieves the load from the filter table, and telegrams traffic across the lines and areas is reduced to a minimum. In any case, it is advisable to connect the PC on which the visualization is installed to the UPS. So always you should connect the server, mini server, the monitoring system to the UPS. And I should say that some nice manufacturers in KNX provide us the redundancy in server and mini server. Okay, so you have the redundant server or mini server, and also you connect the redundant and the main server also to the UPS. In general, however, a control option should always be provided next to the PC to ensure emergency operation. This can take the form of switch sensor or panel units, for example. So we mentioned it before. Another safe planning we said is, for example, you want to control some lights, okay, for two rooms, room number 1 and room number 2. In room number 1 we have the channel A, and channel B. In room number 2 we have the channel A in channel B. The book said it is better to use 2 switch actuators, okay? Each switch actuators with one output from each switch actuator. We only control one light in a room, and for the other light in a room we use the second output of that switch actuator. Okay, so it means if we lost one of the switch actuators, still our rooms are not dark because the second one is work. So you have a room, okay, it has 2 lamps in it. You connect the first lamp to the switch actuator number 1, you connect the second lamp to the switch actuator number 2. So you connect the first lamp to the channel A of switch actuator number 1, you connect the second lamp to the channel A of switch actuator number 2. So if you lose switch actuator number 1, still you have the switch actuator number 2 on and the room is not dark. You see, the book provides the example door lights or window lights, some light near the door and some light near the window. Yeah, this is so nice. Of course, the implementation is not easy in a project because the wiring in electrical cabinet, you should take care of it. And also the person who do the electrician should take care of the wiring from the in the terminal of the electrical cabinet. It is so important, but as a result it is so safe. It is really rare that you lose 2 switch actuators at the same time. For most of the time you lose one of them. So if you lose one of them, the light stays on. Okay, the benefit of line coupler. To my experience, if you use more line coupler, it is much better. Okay, the drawback is it makes your project a bit expensive because you should pay more for the line couplers plus power supplies, or you should pay more for the IP router. Okay, but we have many benefits from it. Let's go and see what books provide for us. The more line couplers are installed in a system, the better the structure and reliability of the entire installation. The basic requirement is, of course, the proper commissioning of the filter tables to reduce the total number of telegrams in a KNX system and to avoid repeat telegrams. The fastest possible information transfer is thus guaranteed. That the failure safety is considerably improved by the electrical isolation. So in line couplers, we have the electrical isolation between the primary line and secondary lines. It should be 1000 volts, okay? Our line segment, we have the line couplers. Short circuit, over voltage, and other signal defects can thus be limited to line segment. Some shock is, for example, provided in a main line. It is not going to the line, okay? Because it has a electrical isolation. To avoid the build-up of telegrams via the controllers, telegrams circulating via the logic module due to faulty programming or repeat telegrams, the filter table should be loaded correctly into the coupler and configured, okay? And you know that even if we make the ring in a wrong way, the routing counter prevents the loop. But one of the important things is in line coupler or IP router is always you should download any changes to these devices to make sure that the filter table is fully updated according to your last configuration, link in group addresses, and any parameterization. Great. So power supply is the heart of the KNX system. For example, a 640 milliamp power supply offers the opportunity in most cases to supply more than one line segment with power. Okay, you should use another choke for that. It must, however, be noted that two line segment can no longer be operated if this power supply fails. So if you depend two line segments with only one power supply unit with two output, one is choke embedded, one is choke should be added. So if you lose the power supply, you lose two lines or line segments. To guarantee the operation of a line segment for a certain period without a 230 volt AC supply, there are two possibilities. Use the power supply with battery connection. So some power supplies in a market is connected with the battery. Okay, here you can see this power supply from ABB is connected to the battery. You see here. The main line is coming. Also, there is a connection to the battery 12 volt DC. It can provide 1 hour, 2 hours powers in case of power failure, of course. Yes. Okay, great. Depending on the capacity and voltage, it is moreover possible to control an alarm siren with a flashing light via the switch actuator with the floating contacts. Of course, if you use the security options, you should have the battery inside of your electrical cabinet. And the book said maybe you can use that for alarming function also. Sometimes the second option, sometimes bus device requires a separate power supply. These includes built-in panel PCs with a visualization system running on them or telephone dialing devices which are connected to the telecommunication system. The request is often made that it should also be possible to send a signal in event of main failures. The KNX power supply can be maintained, example, via an uninterruptible power supply UPS for certain period. Nowadays, it is more popular, okay? If you can use the UPS to power up the power supply. So if there is nothing, no supply from the utility, 230 volt, okay, the UPS supported because also UPS connected to the battery. Other 230 volt devices can of course also be connected via the UPS, such as telephone dialing devices, telephone system power supplies for 24 volt binary inputs, which are often used to monitor window contacts. If several line couplers are installed in a KNX systems, each segment should also be buffered. If a monitoring system is implemented with KNX, it is advisable to connect all the sensor and actuators required to the alarm signaling to a buffered line segment. This segment can be separated from the rest of the system with a line coupler. This guarantees a saving as only one line segment must be buffered. Remember that if you use the, for example, motion sensor and smoke detector, okay, in some building based on KNX, and if you want to have the fail-safe planning, it is better to put all these sensors in separate line with their own line coupler, own power supply unit, and so on. Okay, so if something happens in regular operation like lighting, fan coil control, shutter control, and so on, there is no interference with those lines. So this is a fail-safe planning also. You can consider that, as the book said. But to keep the power supply on, it is better, in my opinion, to use the UPS, of course. Okay, another option is use the redundant power supply. Standard KNX power supply, we call it PSU, power supply unit, are primarily used to supply bus segments, line and line segments centrally. Centrally means you put one power supply, power up 64 devices, for example. This means that PSU, power supply unit, is installed per line. If the bus voltage supply should be designed as a redundant, two power supply can be installed per line. It is possible to use two power supplies, but you cannot put it next to each other. You should have 200-meter distance between them. Of course, in some brands like Siemens, the new power supply, you can put it next to each other, but for most of the brands, you should always go to the datasheet and see what is the rules for that device. So consider it, but according to my experience, maybe it's better to keep with one power supply to not make any mistakes. A further possibility of redundant layout is the use of DPSU. It means decentralized power supply unit. A maximum of 8 DPSU can be distributed on a line. DPSU are particularly intended for the supply of a small installation with a few devices. You know, some devices in KNX has its own power supply unit. For example, the Cinco 700 family product from Siemens to control the air handling units, boiler, and so on. Some of them has the provide us the decentralized power supply unit. Okay, so you can connect the device directly to the 230 volt AC, and this device can provide the power supply for KNX devices like 2, 3, I don't know, according to the table in your installation chapter in basic book. But this is not used in a majority, okay? So you can only have some idea about it. In my opinion, it's not the main solution in KNX. Okay. Since very recently, devices are available which combine two electrically isolated power supply in one housing. Essentially, redundancy can be implemented with these type of devices. So the book said there are some power supply unit in KNX, okay, that provide us two separate output that is internally isolated. So we can use it for KNX devices, and if some of them is fail, you can use the second one, okay? But I don't know in market nowadays that this is now early 2022 that provide these two and automatically change it. I don't know, maybe there exists, but or maybe in future will come. Okay. It should be noted that if one power supply fails, the remaining power supply must supply the required bus current. Okay, so another important solution from the book is you use two power supply unit, okay, and connect each power supply unit with the different phase from the utility. Look at this picture. The first power supply unit is connected to the L1, line 1, 230 volt from the utility, and the second power supply unit is connected to the second line of the 230 volt L2, okay, because we want to increase the safe planning. So in one KNX system they can supply from the different source, okay, and you can use two of them in one line, with the one choke you can see here. And then if one of them is fail and the other one is in a line is alive, so we have the fail-safe planning, but you cannot put it next to each other. You should go to the datasheet and see if you can do it or not. When planning the redundant power supply unit, This 230 volt is important, and if you concern more in power supply to the systems, you should use the power supply with separate choke. Yeah, great. So, and the end, these power supplies with diagnostics function. Nowadays, there are many companies provide us the power supply unit with diagnostic functions. That these functions are provided on the group objects. For the early detection of problems via the bus voltage supply, some manufacturers offer power supply with the diagnostics functions. These devices has a bus coupler and can send telegrams on a bus. Typical diagnoses are example early detection of voltage dips, overcurrent or excess temperature. If these diagnoses are monitored, problems can possibly be detected before the voltage supply fail. If there is a bus voltage failure, the system must be frequently brought to a defined state after voltage recovery. Power supplies with an integrated diagnostic function frequently report a voltage recovery with a time delay and send their status cyclically so that defined recovery procedure can be implemented. Okay, look at the ABB power supply units with diagnostics. Really nice. We have the in operation, always cyclically we receive the telegrams that the power supply is on. Okay, we have the measured value, bus voltage, bus current, current voltage, total current, status and overload. So we have all needed information coming from the power supply unit, and we can use it and make the alarm. But remember that in KNX, if you want to use the key information, okay, you should report or transmit these data to other line. Okay, for example, you have the monitoring in main line, your power supply unit is in secondary line with diagnostics. The information from the diagnostics always should go to the main line to make the decision, okay? Because if it's in its line, so if something's happened, what do you want to do? Great. Thank you, my friends to listen to these chapters. I hope I have been able to provide you nice information. Always you can go to the KNX book, advanced one, and study more. Thank you so much, and I hope you would have a great times in your life. So see you later in next chapters.